Hello everyone, my name is Madurai Kalyan Satvik and now I am going to explain about my internship project done online on embedded systems provided by Emertxe Information Technologies. Coming to the table of contents, firstly I will give you the introduction of the project. Then as a part of the project I have learnt about embedded C language. So we will be talking about embedded C language, then embedded system and its components, then what is a microcontroller, then we will be talking about PIC microcontroller, then the softwares used and the peripherals used in the project. Then I will give you the project demonstration video and then I will conclude my project. Introduction. As we know, in today's modern world, automation plays a crucial role in improving efficiency and reducing human effort. One such example where the automation plays a crucial role is washing machine, which has become a common household appliance that simplifies daily chores. So to understand and replicate the working of a washing machine at a basic level, this project presents a washing machine simulator built using PIC16F877A microcontroller. Embedded C language. C is widely used in embedded programming due to its speed, portability and close to hardware control. This makes C very suitable and reliable for developing this project. With a clear understanding of variable types and their appropriate usage in embedded systems ensures the efficient memory management. And then embedded C also allows direct access to hardware registers using pointers, which is essential for real-time control and performance tuning. Coming to the point of control flow and decision making, loops and conditional statements and logical structures are used to create a program flow that reacts to hardware and user inputs. Like the while loop, which is considered to be the super loop, takes care of ensuring the control flow, as well as the if-else conditional statements help us in making decisions. Modular programming with functions. Functions help organize code into reusable blocks, supporting better debugging, maintenance, and scalability. Also, macros and conditional compilation enable flexible and configurable source code, reducing redundancy, that is, the repetition of the code will be prevented, and supporting the hardware abstraction. Embedded systems. An embedded system is an integration of both hardware and software designed to perform a specific function or task within a larger system. So to perform a specific task, both hardware and software joined together is said to be as an embedded system. Now coming to the common examples of embedded systems include smart TVs, microwave ovens, air conditioners in homes, robotics and automatic systems in industries, flight control systems, then medical instruments like heart monitors and MRI machines, smartwatches, fitness trackers and other wearable tech. Coming to the types of embedded systems. We have mainly 5 types of embedded systems. Standalone or slave standalone embedded system. Standalone embedded system is also known as independent embedded system. Then we have network embedded system. Then we have real-time embedded system. Then mobile embedded system and hybrid embedded system. Coming to the definition of independent embedded system or standalone embedded system, the embedded system which can take decisions on its own without human interference and it has intelligent part in it is said to be an independent embedded system. There is another type in such embedded system, that is slave standalone embedded system, which just blindly follow the instructions given by the user. If you look at the older washing machines, they are the examples of slave standalone embedded system. They just follow the instructions given by the user and that doesn't have any intelligent part in them. Coming to network embedded system. Multiple devices or components together to perform a specific task. Such embedded systems are called as network embedded systems. Examples for network embedded systems are home automation systems, Wi-Fi routers and Bluetooth based systems. Coming to real-time embedded systems. Real-time embedded systems are the embedded systems which are designed to take action or decision within a specific amount of time. These are time-bounded systems where time is strictly followed. If the time is strictly not followed, then there would be a possibility of loss of property or human life. Under real-time embedded systems, we have 3 types of real-time embedded systems: hard real-time embedded system, firm real-time and soft real-time. In hard real-time embedded system, delays are strictly followed. If the delays are not followed, that is, if the embedded system is not worked as it should be, there will be a possibility of life loss. Examples for such embedded systems are airbags and pacemaker. Coming to firm real-time embedded system, here not the life loss but the property loss would takes place if the embedded system is not working as it is expected. Example for that is fire alarm in garments and also rovers. If it is crash landed, then property loss would take place. Coming to soft real-time embedded system, it can accept delays for some amount. Examples are washing machine, microwave oven. There is no property loss or no life loss as we can see. Coming to mobile embedded system, the name itself is suggesting that an embedded system which is movable is said to be a mobile embedded system. Example is a smartphone mobile. Hybrid embedded system. In hybrid embedded system, if more than one category is combined with other categories, then such embedded system is said to be hybrid embedded system. Examples, robots, or we can see these Tesla cars. Components of embedded systems. Now coming to the components of embedded systems have power supply which is regulated in our PICSIMLAB. We will be talking about what is PICSIMLAB in further slides. Then microcontroller, then memory which is RAM or ROM, which is then timer, counter, then communication ports, and then output input ports. What is a microcontroller? Microcontroller is a self-contained system with a processor, memory, and input-output peripherals that is designed to control embedded applications. It takes inputs like button presses, makes decisions, and outputs like turning motors on or off, showing info on the screen. The microcontroller used in this project is PIC16F877A. PIC16F877A has built-in memory, timers, and pins to connect other components. Having all such properties makes this microcontroller reliable and ideal for this project. PIC microcontroller. To build this project, we are using PIC16F877A microcontroller. The specifications of the microcontroller are 40 pins, then it has 5 I/O ports, then it supports serial communication via TX and RX pins, also supports SPI protocol, operates with an oscillator frequency from 4 MHz to 40 MHz. Coming to the objective of this project. The objective of this project is to design and simulate a basic washing machine operation using PIC16F877A microcontroller as we have discussed earlier, and also automating the essential tasks such as washing, rinsing, and spinning. Also, the system should provide user-friendly control and feedback using buttons and a 16x2 LCD, ensuring accurate timing and reliable performance through timers and interrupts. Hardware requirements. The hardware requirements for this project are the microcontroller, that is PIC16F877A, then 16x2 CLCD, then we need buttons for start or stop functions, and also for function of mode selection, then fan for motor simulation, as we cannot use the real motor in our simulator, hence we are using fan for simulating the same. Then the crystal oscillator, then we need capacitors, resistors, breadboards. Also we need power supply, which is 5 volts, is regulated using the software tools. Software requirements: PICSIMLAB, which is a simulator of the washing machine, under which we use PICGenius PIC16F877A microcontroller board. Then we use MPLAB X IDE, which is used as an IDE, where we will be programming the whole washing machine program, and we generate the hex file using MPLAB X IDE. Then we use XC8 Compiler for compiling the whole program into machine readable code. Then the peripherals used in this project: LEDs, light emitting diodes, then tactile switches as digital keypad, then CLCD, that is crystal liquid crystal display, character liquid crystal display, then timers, then interrupts. LED, light emitting diode. A light emitting diode is a semiconductor device that emits light when an electric current flows through it. Due to the low power consumption and high efficiency, LEDs have wide applications in electronic industry. Common applications of LEDs include status indicators, as they indicate the status of the program, whether it is start or stop, whether a button is pressed or not. All such status can be indicated by LEDs. Then tactile switches as digital keypad. A button is used to close the circuit or open the circuit. When the button is pressed, the machine goes into on state and the circuit is closed, and when the button is released, the machine turns into off state and circuit gets opened. These buttons are connected to specific input pins for performing specific operations. CLCD, Character Liquid Crystal Display. The main reason for using CLCD is to know about the state of the washing machine, and also to know about the mode selected, the timer countdown, water level, and processed updates. It provides real-time feedback and improves user interaction with the simulator. Timers. The purpose of using a timer is to generate accurate time delays and also control cycle durations. The timer used in this project is a timer, which is an 8-bit timer which possesses both pre-scaler and post-scaler. Interrupts. The purpose of interrupts is to allow the system to respond to real-time events such as button presses and also timer overflow events. When a button is pressed, it can be start or stop. It is an interrupt for the machine which should be responded by the machine, whether to continue the process or whether to pause the process. So in such case, interrupts are used. Coming to the hardware block diagram of the project washing machine simulator, firstly the keypad inputs. We use RB3 switch for scrolling mode as well as mode selection, and also we use RB4 to turn on the washing machine at the starting of the program, also to start washing of the clothes. We use RB5 to pause washing. Then all these keypad inputs are received by the microcontroller PIC16F877A using timer 2 module, which is used for cycle control, and CLCD, which is character liquid crystal display, which is a 16x2 display used for showing modes as well as times. Then using the LEDs and fans, that is motor, we simulate washing as well as spinning methods. At last, when the program gets finished, we use buzzer to alert on finishing the program. Demonstration. Now we are going to start the project demonstration. So as the starting part of the project demonstration, firstly we open MPLAB X IDE, where we have programmed the whole program of washing machine. So as you can see, all the source files here and also all the header files here. Now we will be using the clean and build the main project option to build and generate hex file. So as you can see, the build is successful here, and now the build generated a hex file in this particular destination. As we have seen, the XC8 compiler has compiled the whole program and generated a hex file, which we have seen the destination in the MPLAB X IDE. Now we will be loading that hex file. So we have reached the destination and we can see the hex file here. So I have loaded the hex file. So as it is showing, we should press key 5 to turn on the washing machine. So washing machine has turned on. Now we can see various washing programs like daily, heavy, dedicates, and to see more options we can scroll down, and to scroll down we are using the RB3 switch. We are going to short press and it will be scrolling down. So it has scrolled and we can see whites as the new option, then stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. Again we came back to daily. Now To select any of the functions, we have to long press the RB3 mode. So I have long pressed RB3 by putting my pointer on heavy option. So I have selected the heavy option like that. Now we have came into a water level screen where we can see auto, low, medium as water levels. By using the same button to scroll, we will be scrolling down and we can see high and max as another options in water level. So I am selecting high using the long press option. So I can see that the water level got selected and I have been forwarded to the next screen where I can see that if I press switch 5, that is RB4, I can start the program, and after starting, if I want to pause the washing, then I can press switch 6, that is RB5. So I have started it. So just to check, I have pressed the RB5 button, that is the switch 6. It has paused the washing of cloths. So again to resume it, I am pressing RB4, that is switch 5. So we can see here the function got changed from wash to rinse. So you can see that once the program has completed washing, so it has buzzed with a buzzer which gives an alert that the washing has been completed and we can remove the cloths. And we have uh, completed the program and it has started back to the starting slide. So with that, my demonstration gets completed. Thank you. Conclusion. Coming to the conclusion part, this project successfully demonstrates the simulation of a basic washing machine using PIC16F877A microcontroller. As we can see in the demonstration video, we have used PIC16F877A microcontroller. Along with that, we also have integrated peripherals like timer, which is an 8-bit timer, interrupts that are used for button presses as well as for the timer interrupts. Also we have used push buttons like RB3, RB4 and RB5, and 16 cross 2 LCD, which is used for status indication and to know the mode of washing machine at several instances. So with that, the system effectively automates washing operations such as washing, rinsing and spinning. Now, through this implementation, we have shown how a microcontroller can be used to control real-time processes in embedded systems. The project not only deepened my understanding in microcontroller programming and peripheral interfacing, but also laid foundation for more advanced automation applications in the future. I would also like to thank Emertxe Information Technologies for giving such a golden opportunity to let me explore and know more about advanced automatic applications and microcontroller programming using peripheral interfacing. Thank you.